be starting with lists, which are compound data types which store together group of values. Lists are versatile and can have any items, can have different type of items, but usually items have same type, and items should be separated at comma separated values and between the square brackets. So this is a list. Squares equals, these are square braces, and then comma separated values like 1 4 9. We can have any amount of values and any type. So first can be a number, second can be a string, third can be a boolean, so it doesn't matter. And when we print lists, we just do it like this, or we can iterate over the list using the for loop or any kind of loop in Python. So like strings and all other built-in sequences, lists can be indexed and sliced as well. So you can see right here, we are accessing the first element of the list, which is the 0th index. That's 1 of squares, and you can also do it by adding a negative number, which will give us the last number. So yeah, that's how it works. And slicing returns a new list, and you should be familiar with this syntax. Square braces with -3 and colon. uh, this is the start value, this is the end value. Since we don't have an end value, it just starts from -3. So this should be -1, this should be -2, this should be -3, and it starts from here and then goes till the length of the list. And since the parameter 2 is the second parameter is excluded from the list, it is just shown as 9 16 and 25, and this doesn't go out of bounds as we discussed in the string video. So slice operations return a new list containing requested elements. This means the following slice returns a shallow copy of the list. So if we do this, square braces, and then just a colon in the middle, it just assumes like the start is 0 and the end is the length of the squares. So yeah, so starting from 0 until the length -1 index, it would return, it would have a shallow copy of the list. So yep, that's that. And lists also support operation like concatenation. So we can have a plus operator right here, and these would be the operands, the squares which we defined right here, and then a new list. It can be a list like this or a predefined list just with the variable name, and it would work the same. Unlike strings, which are immutable, lists are mutable type. So it is possible to change their content. We can do it like we can just replace the content. So we can index some values like here cubes is this list, and then we just the third index would be replaced by 64 right here. So then we print the cubes and we get 64 instead of 65 right here, which is the actual cube of 4. So you can also add new items to the end of the list by using list.append method. And yeah, list.append just adds anything which is provided right here to the end of the list. And assignment to slices are also possible, as list is a mutable type and not immutable type like a string. So we can do like this, letters from 2 to 5, that would be 4. So 2 to 4 would be replaced with C, D, and E, and so these letters would be capitalized right here. And if we then print letters, let me just show you this in the terminal. We can do it as a exercise. So let me just paste it here. One mistake that I'm doing is we are not inside of the Python interpreter. So let's just do it. Python 3, we have the Python interpreter with the primary prompt up here, and we can then just paste this, and we have letters. We can print letters, and this would be the prompt for the input, and this would be the output, as we have no primary or secondary prompt behind it, as I mentioned in previous videos. So if we just do letters and index it from 2 to 5, so that would be 2 to 4 actually, because the second index is exclusive and the first index is inclusive. So if we do that, so that would be 0 1 2 from C to 3 and 4 to E. So if we do this and replace it with C, D and E, what would be the answer? Why do we have an error? Okay, so I forgot the codes right here, so that was my bad. This is obviously this is referring to a variable which we haven't defined, so it says that it's we have a name error. Name C is not defined, but we never defined name C. It should be strings. So when we do this right now, see that we this returned a list, and this was a list. We just took a slice out of letters and replaced it with this. We assigned the value of capital C, D and E to this slice of the list, which would now reflect in letters. Why would it reflect in letters? You may ask, because letters is mutable unlike string, so we can change letters after it is defined. In strings you can't do that. You just like indexing a string returns a new string. It doesn't modify the string, or we can't just slice the string and replace the values. We can't index strings and replace the indices as well, but we can do that in letters. Let me show you. So letters, if I do 0 here, that's a no, this is a 0, and I can do hello right here. Hello. So yeah, and print letters then. So this should, the 0th index would be replaced with hello instead of A, so we get hello, B, C, D, E, F and G. So yeah, that's how you do it. Slicing and concatenation. Let me show concatenation as well. So letters, we have it right here, letters, plus we have another list of maybe numbers 1 2 3 and 4. If we do this, it is printed right here. So this is the original list, ends with G, and after it we have numbers which we just added, concatenated. So that's that. Assignment to slices is possible, we just saw that. And length of the list, we can do, what we can do is, since we have modified the original list named letters, we can get the length of letters. So letters, and let me just see if we can do this. Oh yeah, see, this trick came in handy, because we learned that the underscore operator as the last printed expression in it. So this trick from the previous videos came in handy to us right now. So 0 1 2 3 4 5 6 7 8 9 10. So we have with index 0 we have 10 elements, so the total length would be 11, and that's what we get right here, the length of the last expression which was printed, and that's 11. So that's cool to see. Reference to the previous videos, you can check out previous videos if you would like, if you don't get it. And it's possible to nest lists and create lists containing other lists, so that's called just nesting lists. And we can do that. We can say letters, we can say the fifth index, since the length is 11, we can have the fifth index as another list. Another list may contain something different, like special characters or names or roll numbers or something, and then marks. Yeah, and if we then print letters, we have a nested list. So this is the square braces indicate list, and we have list inside of a list. So if we do letters and the fifth index, if we return the fifth index, we would get a list, and if we do it with the fourth index, we would get a string E. So lists can have multiple types, as we just saw right here at the beginning. So yep, lists can have different types, but usually all of them are the same type, which we don't have right here. We have strings here, we have numbers. We actually had numbers that were replaced. Oh, maybe. Yep, so numbers are replaced with a list, and then yeah, but you get the point. We can have numbers, strings, lists, other objects, or anything else we want. So yep, that's that. And yeah, where were we? Yep, lists can be nested. And so here we have first steps towards programming, and we can use Python for more complicated tasks than adding 2 to 2. That was the previous example of calculator, but here we have a Fibonacci series printer, so we can just print Fibonacci numbers using this. But this example is not for beginners, so we can just move forward to the control flow tools. And here we have control flow statements like if statement and for loop. So yep, so first we would be introduced with the if statement. If statement is as you would have guessed, or if you haven't, it is if something is true, do this or do that. So or would be else here, and else if. This is an abbreviation of else if. So elif some condition, and we have an indent here, do whatever is inside this indent. And that's how if elif else statements work. So we have an example right here. If x is less than 0, then x is equal to 0, and print x negative change to 0. So this is where we have an integer input of, like we are prompting a user to input an integer, like just input, and we would convert it to an integer then. And then what we do is, if x is less than 0, so if x is negative, we just bring it to 0, and then print a negative change to 0. uh, elif, if like x equals 0, we just print 0. If else is 1, like else if else is x is 1, we print single, and else we print more. So this is just an example of if, elif, and else statements. We can have multiple things right here. That would be, let me just show you. So we have a terminal right here. We will enter the Python interpreter, and what we can do is, if we can just x equals integer input from the user, can just do this, and then whatever we input, like 5, if we press enter, that would be the value of x right now. And if we do the same thing, if x equals 0, we can do a simple version of it. If x equals 0, then print right here, x is 0, x is 0. Yep, so we can do else. Also we need a indent right here, print x isn't 0. So x isn't 0 for now. X is 5, and we can do that by printing x's value. So x is 5. So how this worked is, we went into the if statement, we evaluated this expression, like x double equals 0. Double equals is the like the equator, so the operand on the left and the right, it equates them, and if they both are equal, it just returns true, or it returns false. So if this whole expression returns true, the if statement would run, because it, that's true. And if it is false and we have elif, so else if, we can just add another statement or expression in front of elif, as we do in front of if itself. And then we can chain any amount of elifs we want, and make them do whatever we want. And the last statement, we could have it, it's optional. It would be the else statement, which doesn't have anything. So if the if statement and elif statements don't match anything, we would be executing the else statement, and whatever is inside the else statement would be then executed. And yeah, that's how it works. So if statements are right there, and the match statements, we would look into them later on. So we move on to the for statements. For statements in Python differ a bit from what we are used in C or Pascal. Rather than iterating over arithmetic progression of numbers like Pascal, we have given the ability to define both iteration step and halting condition. So for loop in Python is a bit different. We can iterate over some things, and like it would just be iterator. It would just be like an iterator. We have words right here, which is a list of things, a list of strings. And for w in words, we just print w and the length of w. So we print, it would go through each and every index of this list that would be stored in w, not the index value. I mean the index value, not the actual index, would be stored in w. And then we print w and the length of w, so the string and the length of the string. So when we are on our first iteration, we get cat as w, and we print cat and the length of cat, which is 3. We print window for the next iteration and the length of window, and then this whatever this word is, and the length of that word. So yeah, and the code that modifies collection while iterating over that same collection can be tricky to get right. Instead, it is actually more straightforward to loop over a copy of the collection or create a new collection. Yep. So if we have a collection right here, this is a sample collection of user. This is actually a dictionary which we would learn later on. I can discuss about it, but this is just a key value pair. So Hans is a user which is active, Eleanor is a user which is inactive, and we have a unknown user which is active. So the strategy is to iterate over a copy or create a new collection. You would see both the strategies right here. So for user and status, this we are unpacking this dictionary. Unpacking comes later on in the course. So just know that when we use a tuple or just two values right here, that's how we unpack the dictionaries. And first value would have the key, second value would have the corresponding value of that key, and then in for keys and values in users dot copy dot items. So users dot copy creates another copy of this users dictionary, and dot items just gets us the items in key value pair. So we can refer to them here, and we can unpack those. So yep. And if status is inactive, we are deleting the users which have the key of user. So how this works is, let me just give you a sneak peek into dictionaries. Dictionaries are indexed by their keys, not with integers like we have in strings and lists. So dictionaries are actually indexed with their keys. That's why we have user here as key and status here as value. And if the status is inactive, which is the value, if this is inactive, so we have Eleanor right here who is inactive, we can delete. This is the del command. We can delete the users with the value of user. So this command right here is used to delete objects, and since dictionary is just a collection of objects, it deletes the object in itself. So inactive object right here, Eleanor, in along with its value, would be deleted totally, because items is a key value pair. It can't be separated. So yeah, this deletes the Eleanor who is inactive right here. And we iterated over a copy, so this just deletes like if we had a copy, and we can print this we can print this inside the for loop right here. After we delete this, uh, we can print users dot copy, so that would have our like Eleanor won't be there. So the next strategy is create a new collection, and active users, we have active users right here, and for user and status in users dot items, we are using the original dictionary right here, iterating over its items meaning both key and value. And if the status is active, we just push it into active users, and we push the user right in. So yeah, so we put active users, and this would be the key which we index within the dictionaries, and this would be the value which we assign it to with the equals operator. So that's for the for loop and some for dictionaries. And next we have the range function. So the range function, if we need to iterate over a sequence of numbers, we have a function called range which comes in handy for it, and it generates arithmetic progression. So for I in range 5, and this is not inclusive. So when we write range 5, it goes from 0 to 4. So 5 minus 1 4, and when we print it, we get 0 1 2 3 4, and given endpoint is never part of the generated sequence. So yep, this generates 10 values. So range 10 generates 10 values, but it starts from 0. So yeah, it is quite useful for when we have to index or some list or something. Yeah, and we can have two arguments as well. First one would be the start, second one would be the end. And as slicing goes, like as you know, in slicing, first index is inclusive and second index is exclusive. That's the same thing right here. We can have a list of range from range 5 to 10, and 5 would be inclusive, 10 would be exclusive. So we get the list from 5 to 9. And we can have a third argument would be of this of step. So if we let me see if we have it right here. I guess we don't have the explanation for step, but let me just clear that when we have a step right here, this is the value which we would increment or decrement by for this range of values. So for if we are creating a list from this range, and range is from 0 to 10, and we are incrementing by 3. So first is 0, second is 3, third is 6, then 9, and then we increment by 3. But this is out of bounds, so out of bounds of this range, so we just don't add it in the list, and this is our whole list. We can also have negative values, and negative values, as you know, they just add up. Two negative values just add up and have the negative sign in front of them. So this is how it works, just as this example, just a little bit tricky if you so to iterate over indices of a sequence, you can combine range and length, and which would be as follows. So this is a really clever way to do iteration over something with its indices. So we have a list right here. So Mary had a little lamb. I guess, I mean, I wish she had it right now as well. So let's just leave that. But for I in range of length a, it goes from 0. So this is just the end right here. If you have a single parameter right here, so this is the end. Starting would be from 0, and we print I and a of I meaning the index I in list A. So we would go from 0 to 4, because the length is 5. 0 like 1 2 3 4 5, length is 5, so we would go from 0 to 4, which are 5 elements, and we would print all of the elements because we are indexing them right here. So that's it. And yep, we have another way which is enumerate over a list, and it's not shown right here. So let me just show you in our interpreter. If we have a list which equal 1 2 3 4 5, we have the list. We can print the list and it would print us the values. But if we do uh, for I in enumerate, and if we would do list right here, print I, and the end would be nothing. And so we would enumerate over this list. It means that uh, we would get actually two values right here. uh, I just fucked up, so let me just back off from here. uh, yeah, so you see it provides like 0 1 1 2 2 3. Yeah, this thing, it just gave this because we just had one value right here, but we should have two, because the first one is the index and the second one is the actual value. And the index right here we have as 0 1 2 3 4, and the value is 1 2 3 4 5. So it printed as we wanted it to. But if we had another list right here, let me just get out of this and clear the screen first of all, and then go to Python 3. Oops. ah. So Python 3, and yeah, so if we then have a list of something else which should be names. So what are some names? Anything, just random things close to me. Yep, so we have a list like this, and we have to enumerate for I meaning index and V meaning value right here. In enumerating over a list, and then we print the first index, the ith index and its value. So if we do this, we get 0th index book, first index mouse, second index keyboard. And with enumerate we would get the benefit of the for loop, which we normally use like in other languages. We have, let me just nano it right here, nano test or something, like just test maybe. So it won't matter because we are not running this file. So normally in other languages we have for loops like this. So for I would give an example of Java. Int I equals 0, I less than some length of lists, which should be list dot length. And then I would go plus plus. We would have it right here, and we would have it as print I and the index, so list of I. We would have it like this for the optimal solution. And this like, let me just tell you, the Python version is far more better and superior than this, just in terms of getting how the, like, understanding how it works, because we have an integer I equals 0 right here, and then it should be like until it's less than the list length, we just plus plus, so increment it by 1, and then we print the index and whatever is in the list at that index. So let me know, like, if you like this, if you like this more, or if you like this more. So we have the index right here, we have the value, and then we enumerate over the list and print the index and its value. This is much more better syntax to just understand. So yep, that's it. Let's go back, and what do we have next? So in many ways the object written by the range behaves as if it is a list, but in fact it isn't. It's an object which returns successive items and desired sequence when iterator, but doesn't really make it a list, just saving space. Yeah, so I mean, this just prints things. It's not a list. It just prints things, and if this looks like a list to you because it's enclosed in a list function, so not nothing to do with the range function. Just whatever is outputted by the range function is just put in the list right here, so that appears to us as a list. So that's why. And yeah, we can say the object is iterable. So yeah, whatever is returned by the range function is an iterable is intermediate concept, or you can say, I mean, it just comes later in the course, you will have to wait for it. So next step is the break and continue statement and else clause on loops. Yep. So everything here is just self-explanatory. The break statement breaks out of innermost enclosing for or while loop. While loop we haven't seen, but it's just like a if statement, but it loops. That's the thing of it. We just go to Python interpreter, and if true, print yes. We do this, it prints yes. Why? Because the expression inside the brace is right here, the parentheses right here is true, so it prints yes. And for a while statement, so while true, if we do this, print yes. So you would think I would run this, but this is a stupid idea. Just because if I run this, it would run forever, and you might not like this video might not end. uh, yeah, but jokes aside, while true and print yes, this really executes forever for your interpreter, and then the memory is overflowed, and then the program stops. You might not see smoke coming from my laptop because it is quite brand new. Just kidding. This stops before the memory overloads and gives us an error. So yeah, just runs forever. We can do Control Z to exit out of it because we don't want our laptop to explode. Uh, yeah, so that's that. While loop is just like an if statement, but it loops forever until you provide a break statement for it, or no, continue doesn't work. Continue just skips. So I will tell you about it later on. So within a for and while loop, you can include an else clause as well. So in a for loop, the else clause is executed after the loop reaches its final iteration. So that's self-explanatory. After the loop has its final iteration, this what do I have here? So as soon as we break, the else statement would run. Nope, it won't run. Yeah, I kind of knew this. I just had to reread it. But in either kind of loop, the else clause is not executed if the loop was terminated by a break statement. If it exits out of the loop naturally, the else statement is run, or else it is run. And while loop is executed after the loop conditions become false. Oh, yep. So after the loop exits naturally, instead of a break statement, the else statement will execute. This is exemplified in for loop. So yep, this is the function which they give an example of. And yes, this code is correct. Else clause belong to the for, not the if statement. Yep. We can also do this right here in our Python interpreter. We can do is while true, we just did this, but we can do this stupidity once more. And while true, uh, what we can do is nothing. So let me just first give this a variable I equals 0, and while, so while we don't have to keep parentheses in Python. So while I is less than 9, let's say, we just print I. so we just print I, and then if it is so I say less than 9, so when it's 9 it would print it, and if I is less than, I mean I is equal 6, we want it to 6, and I equals 6, we want it to break. Yeah, whoops. Where did we fuck up? uh, that's a long fuck up, so we we can't fix it. Let's just go back to the example. We will do is x, oh yep, we never incremented I, so I equals 0, and Python interpreter, just me forgetting things, I equals 0, and while I is less than 9, just run this loop normally, and if I equals 5, break right there. So break right there, and if not, just keep printing I, and then we would do I plus plus, or I plus, yep, I plus plus. Whoops, syntax error, should have done I plus equals 1. So let's just make a file for this, because I am just doing too many mistakes. Nano test.py, so x equals I equals 0, while I less than 9, what we do is print I, and if I equals 5, we break, and the else statement would be for the while loop right here. Else what we do is print loop exited naturally. Yep. So we almost forgot. Yes. Yes, so we almost forgot I plus equals 1, and yep, that's it. So we run now test.py, python 3 test.py. Oops, we syntax error, we didn't have this. So this nano test.py, we would have it right here, and we would also indent this just as best practice. We would run this, yep, and we get 0 1 2 3 4 5, and that's because if we nano this, it goes to 5 and then it breaks, but it prints before that, so it prints 0 until 5, and when it's 5, it prints 5 first. It checks if it's 5, and it is 5, so it goes inside the if and then breaks, and the else statement doesn't run, because we broke out of it like not so naturally, so that's why it happens. Yeah, and if we had it like this, yep, it would go to 9 and then exit. I fucked up again. Where did I do that? Yep. We don't need an if statement right now, so yep, get out of there. Yeah, so right here we, yeah, so why this has happened is if we nano this, For this statement, while I is less than 9, so when I is actually 9, this statement is false and the loop exits naturally, and it then goes into the else statement and prints that the loop exited naturally. And we can see right here we don't have a 9 because we are checking in the while, so the statement is false and then the loop exits naturally and executes the else statement. It didn't right here because we terminated the loop by the break statement. So that's that. And what do we have right here for more try statements? Nope, we would check that later on. Continue statement, yeah, it just we use continue when when we want to skip. So instead of breaking right here, it would skip that iteration. So if num equals 2, it would do whatever is right here and then the just skip the whole for loop after this statement. So it would just return to the for loop and do its next iteration. Nothing special right here. Past statements are just placeholders for when we have to declare something, but we don't have to yep, so we don't have to implement it, we just have to declare it, that it would be right here and it would be used, but we don't know the use of it currently. We would just have past statement right here, and this wouldn't give any errors. Normally it would, like why is there a while true statement just sitting there, why is there an empty class, it would ask us that. And the past statement just ensures that it the Python interpreter doesn't do that. So if we control L to clear the screen, if we have a class, my class right here, and this is an empty class, we get in the base intent level, so no indentation, and we press enter, we would have an indentation error because we just have indents and we have nothing inside the class. If we would like it to be like it to not throw any error, if we would just like to have the empty class, and uh, we would like to define this empty class, but we would like to implement it later, we can just add a pass statement right here and then press enter. It wouldn't matter. So it just looks over this, and if it says pass, okay, yeah, this does nothing, that while loop does nothing, this class does nothing, and the Python is like, okay, if it does nothing, I don't have any beef with it. So yeah, then we have the match statements, and match statements are uh, an expression takes an expression and compares it to the values with successive patterns given in one or more case blocks. So this takes in an value, it could be from anything. Here it is from a function, and parameter from a function, just match status with the cases of 400, 404, 418. So these are actually status codes right here. So 400 is a bad request, 404 is not found. If the status match with the case right here 400, it would return bad request. And it could have anything, like we can have any amount of cases right here. Like the cases would have to be indented inside of the match statement, and we would have anything we would have to run inside of the cases, indent in like you know how indentation works. So yeah, that would be it. And the underscore, it is treated as the default value, so if none of these cases match, the case underscore would just return, it would just be treated as default, and anything under it would be returned. If we don't have this, we don't get any error. It's optional, but it's just works as a default. Yep. So if no case matches, none of the branch is executed, and you can combine several literals with a single pattern using this or like literally the word or, just like this. So for the 400 series of the status codes is like is bad. So the error, something like error. So if the case is like we have status of 401, 403, 404, we return not allowed. So these are patterns actually. And patterns can look like unpacking assignments and can be used to bind variables. Yep. So match point. So point right here would be a tuple. We would later explain it in detail. But if we are expecting point as a tuple and we provide a tuple with 0 0, so that's the origin on the xy axis. And if we have 0 right here and some value other than 0, any value other than 0, that would be in y, and it would print the value of y right here. If we have anything else than 0 at the x position, it would print x. And if we had 0 right here, it would go into this case. Or if we had both the values, it would go right here in the xy, where we have both x and y defined and not 0. If it was 0, if x and y were defined in the point and it was 0, it would be caught right here. And if we have something else, so someone wrote their name, that would go inside the default case and raise a value error that this is not a point. This is not a point on the xz axis, so that would throw an error. Yep. So yeah, that's shown that a pattern can be used to capture a case of the match of whatever we are trying to match. And